Hello Year 10, today we're doing our last method for sketching parabolas, which is using the quadratic formula and the discriminant. So sometimes it is just not possible to factorize an equation to find the intercepts, or putting something into turning point form by completing the square just isn't a very nice way to do it. So the quadratic formula is another tool that we have to help us find our x-intercepts. So parabolas in the form y equals ax squared plus bx plus c may be sketched using the following technique. So there's some steps outlined here for us. Step number 1, we want to find the x-intercepts by letting y equal to 0. So we've done this many times before, and we want to solve for x. It might be a difference of two squares, a cross method, or a quadratic formula. So we could use any of those methods. Today we're going to be focusing on the quadratic formula though. Then step 2, we want to find the y-intercept by substituting that x equals 0 into the equation. Step 3, check the nature of the turning point by looking at the value of a. If it's positive, then the curve is concave up, which means it has a minimum turning point. If a is negative, the curve is concave down, which means it will have a maximum turning point. Step 4, find the x value of the turning point by using the formula x equals minus b over 2a. You may also find the x value of the turning point by averaging the x-intercepts. Step 5, find the y value of the turning point by substituting in the x value found in the step above into your equation. And finally, step 6, write the point as a point. That means by putting it into brackets with the x value followed by the y value. Okay, so we have done most of those steps before. The only new thing in there is that we will be using the quadratic formula as well to help us for some questions. The other extra part in there is that sometimes we will not be able to find any intercepts, and we can use the discriminant to work out how many intercepts there should be. So remember that the discriminant is b squared minus 4ac. So if you sub your values for a, b, and c into your discriminant and you get a negative number, you know that you're not going to have any solutions to that quadratic. So factorizing it using the quadratic formula, you're not going to be able to get a solution. Okay, so let's jump into the question so you can see how this works. Example number 1. Consider the parabola y equals 5x squared minus 10x plus 7. Determine the number of x-intercepts. Okay, so we could just try to factorize it or use the quadratic formula, but to save ourselves some time, this is when using the discriminant can really help. So let's do that. The discriminant is equal to b squared minus 4ac. Now for my equation, the a is going to be the 5, b is the minus 10, and c is the positive 7. So when I substitute those in, I have minus 10 squared minus 4 times a, which is 5, times c, which is 7. When you calculate that, you get a negative 40. Now that number is less than 0, a negative number, so that means that there are no solutions or no x-intercepts. Okay, so factorizing is not going to work. Quadratic formula is not going to work. I can save myself some time. There are no x-intercepts. Part B says determine the y-intercept. To find that, we sub in when x equals 0. So into the equation, I would get y equals 5 times 0 squared minus 10 times 0 plus 7. Now, anytime you're subbing 0 in, that's going to be 0, that's going to be 0. All you're going to have is that 7 on the end. So my y-intercept is y is equal to 7. Part C, use this formula, which hopefully you remember is the axis of symmetry formula, to determine the turning point. So it's using the same A, B, and C as before. x would be equal to minus from the formula. B is minus 10, so that's 2 minus, it'll make a plus 10 over 2 times by A, and A is 5. So 2 times 5 is 10, so I really have 10 divided by 10, x is going to be equal to 1. Now that's just the x value, but the question actually wanted me to find the turning point. Okay, so that means I need the y value as well. So we have to now substitute the x value into the original equation to find y. So that is y equals 5 times by 1 squared minus 10 times by 1 plus 7. When you calculate that, you get y is equal to 2. So my turning point, or TP for short, x is equal to 1, y is equal to 2. All right, on to the next page. Question number 2 says, consider the parabola y is equal to 3x squared minus 2x minus 6. Sketch the graph showing the y-intercept, the x-intercepts, correct to 2 decimal places, and the turning point. Okay, so we don't know how many x-intercepts, if any, that there are going to be. So what we're going to do is we're going to use our discriminant again to work out how many solutions we're actually looking for. So the discriminant is b squared minus 4ac. Then my a is going to be 3, b is going to be minus 2, and c is going to be minus 6. Let's sub those into that formula. So that is minus 2 squared minus 4 times a, which is 3, times c, which is negative 6. Calculating that, we get 76. Now, the number itself is not important, just that it is positive, that it's greater than 0. When any number that you get that is greater than 0 tells us that we are going to have 2 solutions, or 2 x-intercepts. Okay, so we could then try different techniques to try and find those solutions. So we could use factorizing. It's not a very nice one to try to factorize. We could try turning that into turning point form, but there's a bit of a clue in this question when it says to find the x-intercepts correct to 2 decimal places, that these intercepts are not going to be particularly nice. So we can use our quadratic formula in this instance. So the quadratic formula, as you may recall, is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. So from my equation, using the same a, b, and c as before, I would sub in and get minus 2, so become a positive 2, plus or minus the square root of b squared, which is minus 2 squared, minus 4 times a, which is 3, times c, which is minus 6, over 2a, so 2 times 3. Now, we can do this in a couple of steps. First of all, we would work out what is underneath that square root sign. When you type that into your calculator, it actually comes out to 76, which we probably should have known because here it is up here, 76. The discriminant is that part underneath the square root sign. So we have 2 plus or minus square root of 76 over 2 times 3, which is 6. Now that's my intercepts in exact form, but we've been asked for 2 decimal places. So you would then type those into your calculator. You would go 2 plus square root of 76 all over 6, which is 1.7879 when I round it. Or change that sign to a minus sign. Oh, what happened? Oh, I've done something wrong there. Anyway, I won't type it all in again. That was minus 1.12 is what you should get when you type that in. All right, so we have found the x-intercepts. We now want to also find the y-intercept, which will be when x equals 0. This is always the easier one to do. So subbing x equals 0 into that equation, remember that means that anywhere that there is an x is just going to become 0. So you can type or write down 3 times by 0 squared minus 2 times by 0 minus 6. But really, you know that these are just going to do nothing. And you're just going to get that y is equal to minus 6. We've found the intercepts. The last thing that we need to find is our turning point. So we have two different ways of finding the turning point. We can either use the turning point formula or we can average our intercepts. Since our x-intercepts have already been rounded, it is probably more accurate if we use the formula. So to find the turning point, so TP, to find the turning point, I'm going to do x equals minus b over 2a. That's our turning point formula. Subbing in, b is minus 2, so minus minus makes a plus 2 over 2 times by a, which a is 3. So 2 over 6, which simplifies to be a third. X is equal to a third, is the axes of symmetry. But to get the turning point, we need to substitute that value into our equation. So that's y equals 3 times by a third squared minus 2 times by a third minus 6. Type that all in. I won't do it for you since that just takes a lot of extra time. We should get minus 6 and a third. So the turning point, x equals a third and y equals minus 6 and a third. Okay, so after all that working, we now have all the information we need to sketch our parabola. So in the space you have left, draw up your Cartesian plane. X-axes and y-axes. Okay, the first thing we found was our x-intercepts, which were at 1.79, which I'm going to put here, 1.79, and minus 1.12, which would be about there, minus 1.12. My y-intercept was at negative 6. So let's put that there, negative 6. My turning point was at a third, minus 6 and a third, just slightly past there. Okay, so you could put those on the axes. If you don't want to make it messy though, you can write the coordinates here as a point. So a third, minus 6 and a third, which will keep it a little bit neater. Okay. Just everything has to be labeled. All right, and that is it. So that is using the quadratic formula to sketch a parabola.